Hello everyone, I will continue talking about the dynamic network driving nanostructures. Just as my classmate mentioned before, the article discusses the use of DNA theta-hedra network as a model system to study the dynamic rearrangements of protein structures. This study outlines the use of DNA theta-hedra scaffolds as functional units to construct constitutional dynamic network known as CDNS. So these dynamic reconfigurations of this network is demonstrated through different experiments that involve adding specific strands of DNA to selectively stabilize and destabilize the constituents of the cDNS. This design of the DNA tetrahedra network of enhanced complexity serves as a model for protein-protein complexes driving targeted catalytic transformations. And the study provides a better understanding of protein-protein interactions and the complex biological transformations that they cover. Just as mentioned before, this article discusses two different experiments in the dynamic network driving nanostructures, and they mentioned these four components used: A, B, A prime, and B prime. The first example discussed in the article involves using DNA theta-hedra scaffolds as functional units to construct controlled dynamic networks that emulate the dynamic control over the contents of protein-protein complexes. So this first experiment describes the use of three different sized DNA theta-hedra as functional components to assemble a complex mixture of four constituents called CDMP. As we can see here, we have three different sizes of DNA theta-hedra: big, medium, and small, and this is the CDMP. Each constituent is functionalized with a different magnesium ion-dependent DNA SIME unit that acts as a reporter element for the content of the constituent in the calibrated cDNS. By probing the rates of cleavage of fluorophore canker modified substrates and using appropriate calibration curves, the concentrations of the respective constituents were evaluated. So when subjected to the full strand T1, which is stabilized constituent A prime, the CDNP is reconfigured to CDNQ, where constituent A prime is upregulated, while constituent B A prime and AB prime is downregulated, and constituent B prime is upregulated. So the reverse displacement of T1 by the counter full strand recovers CDNP. Treatment of CDNP triggered T2, which is stabilized constituent BA prime, that results in the reconfiguration of CDNP to CDNR, where constituents BA prime and AB prime are upregulated and constituents A prime and AB prime are downregulated. So the dynamic reconfiguration of CDNP to CDNQ or CDNR and the control over the contents of the respective constituents provide a model network that emulates the dynamic control over the contents of protein-protein complexes within a mixture of macromolecules. So the second example focuses on the design of a DNA theta-hedra network of enhanced complexity that guides gated catalytic processes as a model for protein-protein complexes driving targeted catalytic transformation. This article describes the design of the DNA theta-hedra nanostructures for use as models of transient protein-protein interactions and their applications to create the DNA theta-hedra network of enhanced complexity. The design involves the use of functionalized theta-hedra, donor receptor, FRET, fluorophores, duplexes, nicking enzymes, substrate strands, and inhibitors. So the gated dimerization of the DNA theta headrest structures, gated catalytic processes which serve as models for protein-protein complexes that drive targeted catalytic transformations by subjecting the reaction model to full strands, inhibitors, and other triggers the researchers were able to control the formation and dissociation of the DNA enzyme units and evaluate their temporal transient catalytic activities. These results demonstrate the potential of DNA theta-hedra nanostructures for use in the designing complex molecular systems with applications in biomedicine and nanotechnology. And these examples demonstrate the potential of DNA nanotechnology to mimic transient biological processes and create programmable dynamic networks for a variety of applications. Thank you.